Chalo Priya, let us start. So we were on what you call the chemical properties of sulfuric acid. So when we talk of quickly, we'll do chemical properties and then we'll move over to oxy acids of sulfur. That is very, very important. That's where actually today's focus will be. So we have, when we talk of chemical properties, what happens is the first property is it is a strong dehydrating agent. It is a strong dehydrating agent. D means removal, hydra means water. It removes water. Dehydrating agent. It's a strong dehydrating agent. Is this point clear? Example is you can take is formic acid. HC double bond OOH and concentrated sulfuric acid. You get H2O and CO2. You get carbon monoxide and water. So this is one method of preparation of carbon monoxide. You say, sir, why not the other one? That is what you learned. Burn carbon in limited supply of air or oxygen. There is a problem. Some amount of carbon dioxide will always be there. So this can be a method of preparation of carbon monoxide. Here the carbon monoxide form will be far more pure in nature. Is this point clear? Now look at glucose. C6H12O6. Simply treat it with sulfuric acid. What happens? You get carbon and H2O. It's simply because what is the general formula for carbohydrate? CxH2OY. Complete H2O is removed. You are left with only carbon. Is this clear? Then we look at what? Oxidizing property. Let us look at the effect of, so we have the EMF series. You have hydrogen. We know it is 0.0 volt. We know it is 0.0 volt. So there is an element below hydrogen. What is the element below hydrogen? We have zinc. Okay, zinc plus 2. And we'll take the example of copper. Copper plus 2. So this element above. Let us see the reaction. So when for elements below hydrogen, in EMF series, for elements below hydrogen in EMF series, that is zinc. What is the action? Zinc plus H2SO4 forms zinc sulfate plus H2O plus SO2. Is clear? Same way for elements above hydrogen in EMF series. Example is copper. Copper plus sulfuric acid forms copper sulfate plus SO2 plus H2O. Then we come to dilute. See, the oxidizing property is going to get reduced. Dilute sulfuric acid. With dilute sulfuric acid, what is going to happen? Dilute sulfuric acid is not a what you call oxidizing agent. Remember that. Concentrated sulfuric acid is oxidizing agent. Okay. So dilute sulfuric acid, element below, what is going to happen? Element below, let us say zinc plus H2SO4 dilute is going to form zinc sulfate plus H2O plus hydrogen gas is evolved. Then with copper, what is going to happen? It may not react. Copper, no reaction. So this is the difference. With concentrated oxidizing action, We dilute, here what happens, it is removing hydrogen, copper metals above, no reaction. This is clear. We have an interesting example over here. 1 minute. The interesting example over here is, I don't know why they have mentioned this, it is K4FeCN6. K4FeCN6, if you react with sulfuric acid, what is happening is you are getting KHSO4 plus FeSO4 plus ammonium sulfate and carbon monoxide. I mean, I've tried to reason out what kind of a question can be framed in this. I have not been able to reason out what kind of, I mean, they can just ask, this is the only possibility which I thought, that action of sulfuric acid on potassium ferricyanide, the one of the product obtained is, see, carbon monoxide may not strike you, that we'll get carbon monoxide. So that could be the only relevance over here. Now, if you have, that's all. I mean, take the, I'll just read through the uses because not much to talk about. Mainly it is used, so it's a, I told you it's a king of chemicals. I mean, that country which uses maximum sulfuric acid is having a higher GDP because that much is the importance in industry. I told you Germany, hardly the size of Maharashtra, is, I think, using more sulfuric acid than the whole of India. It's clear. So because German chemical industry giants are BASF, Bayer, Degussa, they are big companies. It's clear. Some of them have a total global turnover as good as India's budget. Sulfuric acid is used in what preparation of chemicals like nitric acid and all that, phosphoric acid, commonly used. It is dehydrating agent used in lead accumulator, all that we have seen. So that's all that is there. Okay, take down. And then we will come to what? We'll come to oxy acids. There is a very important use because one board question has been asked in this. Sulfuric acid is used as a pickling agent. So that I will discuss. In uses, it was a give scientific reason. Okay, there was a board question. See, what is it? Sulfuric acid is used as a pickling agent. Sulfuric acid is used as pickling agent. Let me explain what is this pickling agent. See what happens. We have what we call as galvanized iron, GI sheet. Commonly we call it as patra. What is, I taught in electrochemistry. It's basically an iron sheet on which we put a 10 micron zinc coating. It's called as galvanizing. Bombay mein to we see all buildings under redevelopment, patra sheet. Over that they put a blue paint also, extra protection, so it will last longer. 10 projects still use the same patra. So what happens is, if the iron has some iron rust, then there can be what we call as anaerobic rusting. It will rust inside. Okay. So what they do is, before galvanizing, before putting the zinc, they dip that iron in sulfuric acid. So if there is any iron rust, ferrous oxide, it will become ferric sulfate and dissolve. So this removal of the rust from iron sheet is called as pickling before galvanizing. Okay. So pickling agent. Pickling is a process. Pickling is a process for removing basic what? Basic oxides of metals, Fe, okay, before electroplating or galvanizing. Okay, so take down this much and then we'll come to oxy acids today. is the next lecture? Monday, है ना? नहीं, Sunday. Yeah, Sunday. So we'll have 2 lectures, Sunday, Monday. So we'll be able to finish much of 17. काफी हो जाएगा Sunday, Monday तक. करते हैं. One more lecture will require हो जाएगा फिर 17. Priya, you tell me when you are finished, huh? Because yes. So now we are talking about the most important part. The last and the most important part. So listen carefully. What we have is oxyacids of sulfur. What are the different types? So basically we have 5 different series. So the first is we have sulfoxylic acid. So remember, the formula of sulfoxylic acid is H2SO2. So H2SO2 will have a structure. See, S, I told you, central atom is S. You have one OH and you have another OH. H2SO2. So we had a blue pen, na? We need that. So you can see over here, OH has an oxidation state of -1, -1. So in this case, sulfur will have an oxidation state of +2 and it is a dibasic acid. So these are the questions they can ask. Structure, oxidation state of the central non-metal. Non-metal attached to OH is A. Then you have what? The second one is the sulfurous acid. The sulfurous acid series. Sulfurous acid series are what? You have 1. You have H2SO3, the sulfurous acid, H2SO3, and then you have H2S2O2. So I write the name also. Sulfurous acid. Then the next is H2S2O2. H2S2O2. This is thiosulfurous acid. Then you have the third one, that will be H2S2O4. H2S2O4. So H2SO4 is dithionous acid. This is some Bayarting work you have to do. It's against my principle, but I have no choice. Then you have H2S2O5. H2S2O5 is pyrosulfurous acid. Pyrosulfurous acid. So now what is the question? Structure. So we talk of sulfurous acid, correct? What happens? You have S double bond O, OH, OH, okay? So oxygen has a charge of -2, hydroxyl ion -1, this is -1. So it has an oxidation state of +4. It has an oxidation state of +4. This is simple, they may not ask. This is clear. Then what do you have? Thiosulfurous acid will have S double bond, sorry, not O. Of course, this is dibasic. Huh? This is dibasic acid. Now here you can see, here thiosulfurous, this sulfur, I'll write it a little bigger. So this sulfur will be -2. The rule, if you remember, when they are coordinately bonded, then this is supposed to have a swayam dhyan de. A coordination bond hai. We are not writing it as double bond, it's not double bond, it's a coordinate bond. So this will be -2. So one sulfur atom will have a charge of -2. So then what will happen? So -2, -3, -4. So another sulfur will have a charge of +4. So what they are doing is, what is the entrance exam question that they have asked? Ek to they will give name, thiosulfurous acid. So what is the maximum and minimum oxidation state in thiosulfurous acid? So how is the question framed? Where is this? This is now. The question framed is, what is the maximum and minimum? What is the maximum and minimum oxidation state in H2S2O2? They may ask like this. This is true for everything where there are multiple oxidation states. And remember, what is the other question? First question in this is this. Second question is, it has a S double bond S bond. So they will give you 4 of such acids and ask which has a S double bond S bond, which has a SS single bond. So knowing the structure is very, very important. Then we have dithionous acid. So what will be dithionous acid? S double bond O, OH, S double bond O, OH. So you can see over here, this is -2, -3. So each sulfur will have a charge of +3. But what is more important over here is that it has a SS linkage. So in thiosulfurous acid, it has a S double bond S linkage. In dithionous acid, it has a S single bond S linkage. Then we come to pyro. So you have pyrosulfuric, pyrosulfurous. Now we talk pyrosulfuric. It has a SOS bond. So in pyrosulfurous acid, what happens? S double bond OOH, OS double bond OOH. Okay. So what happens in this case is, listen carefully, we have so oxygen has -2, so it's shared by each one of the sulfur. So -1, -2, so each sulfur has a charge of +4. It has a SOS bond, very important. Pyrosulfuric acid also will be the same thing. Huh? So word pyro, you remember, it has a SOS bond. Save our souls. Who will save? I don't know. Is this clear? Somebody has to say it's in real bad shape. So this was the second one. Then we come to the third. I told you 5 series are there. Okay. The third one is sulfuric acid series. It is sulfuric acid series. So which are the members of sulfuric acid? You have sulfuric acid, H2SO4. The structure is S double bond OH, OH. So it's what happens? Sulfur will have an oxidation state of +6. Easy to write over here. Dibasic acid. This is easy, so I'm not discussing much about it. Okay. I told you it's called as oil of vitriol, that I've already told you. oil of vitriol. Then the next one we come to is H2S2O3. H2S2O3. What is H2S2O3? It is thiosulfuric acid. Thiosulfuric acid. So what do we have? S double bond S. See, thiosulfurous, okay, S double bond S. Only thing is it has an additional O, OH. So -1, -2, -4, -6. So sulfur here has an oxidation state of +6, -2 and +6, because this will be -2 and this will be +6. Remember that. So once again the same question, maximum and minimum. So thiosulfurous maximum minimum will be -2 +4, and this will be -2 +6. Please remember that. Thiosulfurous and thiosulfuric. Then what do you have next one? We have pyrosulfuric acid, which is H2S2O7. H2S2O7 is pyrosulfuric acid. So what will be the structure? You have S double bond O, OH. So this is -1, -3, -4, -6. So sulfur here has a charge of +6. It's also called oleum. It's also called as oleum. Okay. Then what do we have? The fourth one. What is the fourth one that we have? It is peroxysulfuric acid. I am marking this very, very important. If you remember, in the 11th standard, when they talked about how to prepare hydrogen peroxide by using electrolytic method. In the electrolytic method, what did we do? It was by electrolysis of dilute sulfuric acid. Okay. And what happened was we got peroxy sulfuric acid. And then that became what? From that oxygen came out into water. It was peroxy disulfuric acid. It became peroxy monosulfuric acid. And then that gave the extra oxygen to water, and that became peroxide. So today I think you have to really go home and revise two things. That how was hydrogen peroxide prepared by electrolytic method? It is clear. By electrolysis of dilute sulfuric acid. Okay. So you got peroxy disulfuric acid, that formed peroxy monosulfuric acid, that reacted with water to give sulfuric acid and hydrogen peroxide. So we are talking about these two. What are we talking about? We are talking about, so the fourth one, very, very important. We are coming across this in 11th standard. Okay. Preparation of hydrogen peroxide. And they got a typical name also. So we have fourth, we have two. This is what? Peroxy. This is called as peroxysulfuric acid series. You have two of them. Which are the two? Peroxy monosulfuric acid. Peroxy monosulfuric acid. It is H2SO5. H2SO5. See, it is simple. You have S double bond O, double bond O, OH. If there was just a OH, it would have been sulfuric acid. But here there is OOH bond. So this is a peroxy bond. Sulfur here has a charge of +6. Because you see, -1 in peroxide, oxygen has a charge of -1. Remember that. So -1, -2, -4, -6. So it is +6. Then we have peroxy. It is also called, very, very important. It is also called as Carros acid. So there are a lot of emphasis on this Carros acid, and the other one is Marshall acid. So you have peroxy disulfuric acid. What is peroxy disulfuric acid? You have a OO bond, and what happens? S double bond O, OH, S double bond O, S double bond O, OH. So -1, -2, each sulfur has a charge of, it is H2S2O8. H2S2O8, one single oxidation state, +6. So pyrosulfurous and pyrosulfuric and thiosulfurous and thiosulfuric. No, thiosulfurous and thiosulfuric acid are the only ones which have got two different oxidation states. Others are A. So here this is called as Marshall acid. This is called as Marshall acid. Lastly, the fifth one, what do we come to? We come to thionic acid. Thionic acid is what? It is H2S2O6. H2S2O6. So what happens in this case? You have S double bond O, with thionous acid we had over here, na? Dithionous acid. So now this will be thionic acid. S double bond O, S double bond O, OH. So what will we have? -2, -3, -5. So here sulfur will have an oxidation state of +5. So this much is what you are supposed to know. With this, we have completed the, what do you call? Yeah, please take down this very carefully, okay? And then we can leave the portal. We'll stop for the day. Next lecture is on Sunday at 5 o'clock. I am starting 17 group. So I think Sunday and Monday we should complete a big chunk of group 70. I need about 3 to 4 lectures, but first two are important. I don't start a new topic today. Take it carefully.
That's why I was like, okay.
I know.
बोला तो था पहले सर